Thank you. Okay. Welcome to the next presentation. This next presentation is on debugging code. Welcome. We are Team 930. I am a programming sub-lead, and with me today is Matt, who is a programming mentor. In today's presentation, I will be going through an overall what is debugging. I'll be going through different types of debugging like breakpoints, unit testing, integration testing, the driver station log, and logging. Thank you. Alright, first, what is debugging? Debugging is determining where and why errors are occurring, or finding out why your code isn't working as properly or as you intended. There's no right or wrong way to debug. It's all about finding what works best for your team or what works best for the tasks that you are testing and trying to debug. When writing code, there is the inevitability of having errors or code that doesn't work as properly as you thought it would. We are at our age being in robotics and programming to learn programming. And that's what comes with learning, is messing up, and fixing that is how we learn. Having debugging skills allows us to learn new code and make successful code faster and more achievable. There are common ways to debug, like print statements, but print statements can often be very messy, hard to manage, and they can bog down the system. In this presentation, I will be going through different ways to debug that are less messy, easier to manage, and have like different functions that will help you debug better. First off, we have breakpoints. Breakpoints are points in the code where it will stop the code until you step over it. It's like stepping through the code, and each step is a breakpoint that you have placed. It becomes really helpful, especially when testing your code and you want to pinpoint where an error is occurring or and find out why the code isn't working. For example, if you have a button that's tied to a command, and that button, that when you press it, the code isn't running as you intended it to, you can place a breakpoint to see if that code is actually running, to see if it's your button tying that made the code not work as you intended, or the actual code. With how to place a breakpoint, you will press the margin outside. You can see the two dots. That's where you press to place a breakpoint. For us in VS Code, there is a tab called Run and Debug, and in there is another tab called Breakpoints. From here, you will be able to manage your breakpoints. You can turn them on, turn them off. You can remove them entirely from your code. There are also 3 different types of breakpoints. When you right-click on the breakpoint point in the margin, it will give you an option to change the breakpoint to either expression, hit count, or log message. Expression is when that expression is true. For example, if count equals true, and when it hits that breakpoint, if that expression is true, then that breakpoint will hit and stop the code. Hit count is if hit count, for example, is 3, if that breakpoint is hit 3 times, then the code will stop. The last type of breakpoint is log message. This breakpoint will not actually stop the code, but it will log a message for you. On the top here, we have breakpoint tools. When running your code, this toolbox will pop up. The pause sign there will pause or run your code. the arrow going over the dot, which is the breakpoint. This will step over the breakpoint. The arrow pointing to the dot steps into the breakpoint. The arrow pointing away from the dot steps out of the breakpoint. The green arrow restarts your code entirely, and the red box stops the code. The lightning bolt we don't actually use, but it is a hot code replace. It is a debugging technique where the debugger for Java transmit the class changes over to a debugging channel to another Java virtual machine. There are a few disadvantages that comes along with breakpoints. You can't place breakpoints on comments. There's no code there, so it's just a comment. We also can't place them on the method declaration. You can only really place them on lines of actual code. Alright, so next is my demo. So in the code I have up is the shooter subsystem. I'm going to place a breakpoint at line 100, and this line of code sets the motor speed. I will go to the run and debug and press play to open up the simulation. I'm going to go into teleop, make sure my controller is the right spot, and when I hit the button that we have tied to this set top speed, it will hit the breakpoint and stop the code. Here I can either play, which continues the code as normal until that breakpoint is hit again. This will step over it and will continue through the code. This will step into the breakpoint and take you to, excuse me, takes you to where that breakpoint is being used. Alright, this one restarts the code entirely, and we'll run simulation again. When a breakpoint is hit, it will also take you to that point of code. Alright. We're going to tell me up, don't get that. Joystick. So it will also take you to that point of the breakpoint that is being hit. Stepping out of a breakpoint will also take you to the point of, and this here is initialization in the toCargo command, so it takes you to where the code is being initialized.
And if you guys look at line 113 is actually the method that she has her breakpoint in, so that's why when you step out, it goes where it's called.
And the grid box stops the code and the simulation entirely.
When you ran it, it looked like it highlighted, but it added more text to the end of that line.
Yes, so it will give you some information about what's going on under the hood at that location, and it will also give you some information about the arguments that are going into those methods. So that's where a lot of that extra information is. Yeah.
Alright, Next we have is unit testing. Unit testing is testing each part of the robot individually, most commonly used when using simulation. This makes sure that each part of your robot can work individually. Why we use it? It is important to know that each part of the robot can function and work properly individually and not rely on other parts of the robot to function. It also makes debugging really easy. Well, makes it easier to pinpoint where the code isn't working properly or why errors are occurring. When would we use unit testing? It is usually used in early stages of testing when we don't have the robot, when there is an error and you need to go back and make sure that each part of the robot is functioning as you intended it to, and making sure that each part works individually. Alright, implementing unit testing. Unit testing is its own separate class. Here we have it testing the shooter math. In all of these different methods, we have it testing every possibility of shooter angle.
Something else to note here is for unit testing, especially in Java, you have to use a third-party library. And in this case, we use JUnit to do our testing. And there's an entire infrastructure that you have to learn. So we can spend an entire presentation talking to you guys on how to actually set that kind of stuff up. And if you are interested, let us know, and that's something we can do next year. But unit testing is kind of a beast in itself if you've never done it before. So we just wanted you guys to know it's there and it's important.
Alright, next is integration testing. It is the opposite of unit testing. It is testing each part of the robot together, all in one, make sure that all of the parts of the robot can work cohesively. Why would we use integration testing? Excuse me. It is important to make sure all parts of the robot can work together. You wouldn't want to get to a competition and realize you can't intake and drive at the same time. That would make competing really hard. When would we do an integration test? This is anytime you're driving a robot, driver practice, just in all testing, when you have the physical robot. It is very important to do integration testing. For example, one time at a competition, we did not do an integration test of the LED code. The LED code did work in simulation, but we did not test it on the actual robot. The entire match, it worked perfectly fine until we got to endgame, and the LED code along with the endgame code caused our robot to crash. I have a video here that is integration testing many different things, and by the end of the video I would like some input of what is being integration tested.
User error. And we made it on the bound.
Yeah, exactly.
Alright, so what are some things that are being integration tested?
I see your intake running at the same time as you're driving.
Mm-hmm.
Your shooter, or your catapult.
Mm-hmm.
Also the LEDs.
The LEDs are working, driving and taking and shooting. In this video we do not have the end game running, so thank you. Next we have is the driver station log. This is a this logs a whole lot of information, such as data, errors, warnings, events, all stored in the driver station. In this first screen, when you open up driver station, there is information that it tells you, like if there's communication, if there's robot code, if there's joysticks, the battery percentage. There will be errors and warnings that will pop up in the message box. But on top of the message box, there's that gear that, when pressed, will give you the option to select different screens. This one will be view file log, and this has many different functions. For example, this first box is called the file selection box. Here there will be different files that you can open up and will give you past history of the driver station being used. The path to files, which is that second box, just tells you the path of the file. The message box on the bottom gives information, gives warnings, errors, messages, and hovering over the graph at any point when there's a line or an event will give you more information about that event. Alright, a deeper look into the driver station graph. Here we have different lines like latency MS, which is how long it takes data to be sent over computer networks. We have packet loss, which is packets are the packs of data being sent over computer networks. Thank you. And packet loss is when those packets are lost. The RoboRio CPU is how much processing power the RoboRio is using. The yellow line between 12 and 13 is the battery voltage, and you can't see it in this graph, but there is a CAN percentage, which is how much of the CAN bus is being used. I have a demo of the driver station. Alright, so here you can see that I do have a joystick plugged in because the little box next to it is green. We don't have robot code or communications. And what I was talking about earlier, this gearbox, this gear here, clicking it will give you the option to select view file log. And this will open another screen. There it is. And here is the graph and all the different files and the message. I did it before. Your computer. It's okay. Down there, the very faint, the green line on the very bottom is the latency MS. The orange spikes you can see are the packet loss. The red lines all over the place are RoboRio CPU. There aren't any events, but events will. No, we don't. Will pop up right underneath the lines on the top as circles. The lines on the top are the robot mode, and they will change. The gray is disabled, the green is autonomous, and the blue is teleop. You can also hide the information. You can hide the robot mode, which takes away what mode the robot is in. You can get rid of basic, which takes away the robo CPU and like battery percentage and can percentage. Then you can take away the packet loss. This is really helpful, especially when trying to view and it looks like that and it's really hard to look at.
Some things to note just real quick before we move on. Packet loss, for those of you not familiar, a lot of times that has to do with how you communicate between your driver station and to your bot. Our experience, we've had a lot of issues between our actual laptops and certain computers versus our robot. And you can kind of get that sense when you look at the packet loss, as well as you can get very good indications of bad radios and things of that nature just by reading your packet loss. That's a big one that we utilize. As well as you can get good information about your CAN bus. For those of you who have issues with finding problems with motors and cans, your CAN utilization should be pretty much 100% usage. Unless there's an issue with the motor, you're not going to use your full CAN. It will stop somewhere between 50 to 75, wherever that bad motor will be. You can get a somewhat indicator that there's a motor bad in your CAN utilization. So just a couple things to think about.
Alright, next is Java logging. What is Java logging? This is a type of debugging that's built directly into your code. This causes it to be different for each programming language. It logs messages so you can later retrieve them and analyze them. There are different levels to Java logging, such as finest, which is a highly detailed message. This gives the most information. Finer, which is less than finest, gives less information, but gives a fairly detailed message. Fine is the least amount of message, which logs like the most important information that you want to have. There's config, which does configuration changes. Info, which logs information messages. There's warning, that is indication of a potential problem. There is severe, which indicates a serious failure, and off, which turns off the logging. There are benefits and disadvantages of logging. With logging, you can name each log separately and change the level depending on what kind of information you want to retrieve. They're also very easily turned off. Some disadvantages is if you forget to turn them off, they can really bog down the system and potentially hurt you if you forget to turn them off during competition. It is initially a lot of code to put in, but it does end up being really helpful later on. So, first of all, we have log level fine. In this example, we have the run intake motors command, and we have the logging set to fine. Why would we want this level to be fine and not finest or finer? Alright.
Is this information you guys want to see all the time when the robot's running, or whenever there's only a problem?
Whenever there's only a problem.
Whenever there's only a problem. So when you set a finest kind of logging, you want to see every kind of detail you can to figure out a problem. Just my heads up.
Okay.
I hate the game. Sorry. You go. Thank you. Alright, next we have is log level finder. And here we have the Limelight subsystem. And here we have the logging set to finer. Why would we set it to finer? And finer, it is the middle ground of the most information and least information, and you can really set it to what kind of information you want to have. Well, there, oh, sorry, I did not
Because
know.
it's important information, you wanna be able to see it.
Yeah. If you're not like actively trying to debug it, you don't need to have the most information, but it is something important that if something does go wrong, you have to know if something goes wrong. Thank you. Next we have is finest, which is the most information. This code example is getting the temperature and sending it to a file. Here, down here, we have the log level finest, and it says writing to a file. Why, what? Alright. Why would we set this to finest?
Because it's information you're most likely not gonna need unless it's a pretty specific issue.
Yeah, it's writing to the file, and basically if it doesn't send it to the file, you won't have that information, and that's important to know. If it does not send to the file. Thank you. Next we have is Java logging info. Here we have is the position of the shooter, no, the climb on. Why would we want this one to be info? Well, this has lots of information that goes with it. It has lots of math and information, and getting that information if something goes wrong is really helpful. Next we have is log level off. Why would we want to set all of our logs off?
Because we don't need them,
Why would we not need them?
because they're not relevant to the thing we're trying to debug.
You know.
You're in a match and you don't want to go using the system.
Yep, exactly. Right. Alright, so it's levels of logging. Fine is the most information. Finer, no, that's opposite. Fine is the least information, and it goes finer, which is the mid, and then finest, which is the most information. When you go to finest, when you go from the most information to finer, you will stop seeing things down the line, like info. If you have info set to finest, and then you turn on finer, but info is not in finer, it will only do things like warning or severe that are more important and give less logging. And
So in a nutshell, think of these as like levels of logs you want to appear. You're gonna assign every one of your logs one of these levels, and based on the level you pick, there's a hierarchy. So if you're at the finest, everything below finest will show up. If you're down to warning, only warnings will show up. None of your logs above will show up. So that's how Java handles all of your logs and under the hood. So that's how you can manage which logs you see. And we can do questions here. Let's sort of wrap up and then we'll do some questions.
Alright, log level severe. Down here, we have the logger set to severe. Again, this is the setting of the temperature. Down here, it says it couldn't open the file for the writing. Why would we want this one to be severe?
Because it's the worst case scenario. It straight up couldn't do anything.
Exactly. Severe is a serious problem, and if that log is logged and it couldn't open up the file, that is a serious issue that happened. Alright, we have log level warning. This one is the indication of a serious problem, or indication of a potential problem. Here we have is the dead band for our shooter. Why would we want warning to be logged here?
So you can detect if something bad's gonna happen before it happens.
Potentially.
It looks like you don't want that angle set greater than or equal to 90. So if it is greater than or equal to 90, you wanna let them know so that that can be fixed.
Yeah. If it does get greater than 90, that could potentially cause harm to either the robot or not accurately shoot, and that is a warning that we do want to catch.
The other thing to think about warnings are, they are errors, but they're errors that might not cause problems in the long run. So if you're seeing weird behaviors, and you're logging your warnings right, it can potentially guide you to a solution to your problem. That's the whole point of your warning logs.
Alright, so through this presentation, I went through debugging, which overall it is determining why errors are occurring in your code. Breakpoints, which are the points in code that stop your code. Unit testing, which is the separate class that tests every possibility that that part of the robot can have. Integration testing, which is testing each part of the robot individually, testing them all together. And driver station log, which is the driver station logging events, data, errors, warnings, and all of that information that makes debugging easier for us. And logging, which is messages that are logged so they can be later retrieved and analyzed. Thank you for coming to this presentation.
Thank you.
Is this a Java class or is this a WPI?
So WPI lived